All right, we're going on to 4.1 and starting out with basic probability. So what is probability? Probability, well, we just break it down into a simple sentence here. Probability of something occurring is the number that represents how likely it is to occur. Now, people think probability means percent chance, and it does, and it doesn't. So here's the problem. Probability cannot be a percentage. Probability has to live between 0 and 1. So probability is the decimal representation of the percentage chance of something happening. So if you looked at the weather today and they said there's a 30% chance of rain, convert percent to a decimal. Decimal's sitting right here because it's not written. To go percent to decimal, you drop the percent sign, you move 2 places to the left. And we find this to be our probability. So our probability is 3/10. So if something has a 30% chance of occurring, the probability of it occurring is 3/10. Okay. Now, what about a probability? How can I get to a probability or find one? Well, sometimes it's something that you can't calculate without an experiment, like someone's free throw percentage or field goal percentage in basketball. Okay. So what you would do is you would create an experiment that leads to outcomes. And then the outcomes, as a result of a single trial. So we're just trying to create an experiment so that we can see what is the likelihood of something occurring. So I was using basketball earlier. Let's just go back to coin flips. All right. If I flip a coin, I get heads or tails, assuming it's fair and everything. But a better example for the ones with an experiment, like if we did heads and tails on a coin, you know and I know that if it's a fair coin, half the time it's going to be heads, half the time it's going to be tails, right? So that is a different type of probability. I can calculate that without doing an experiment. But this example is going to come up later. What's the probability that I go to the gym today? Okay. Well, how can I determine that? Well, the only way I can determine that is I can look back at the past. I can see how likely I am to go to the gym. So I can go back over the last 4 weeks and I can say, did I go to the gym or did I not go to the gym? And then I can look at, here are all the days I went to the gym, here are all the days I didn't go, and from that I can determine the probability that I'll go to the gym. Now, if the outcomes for the probability experiment are going to come out random, that means there's nothing controlling them. We wouldn't say that the something like shooting free throws or shooting three-pointers would be random because some people are better than others at it. All right. And then lastly, this isn't bolded. It's our last vocabulary word here. Probability experiment, the set of all possible outcomes, is called the sample space. So a sample space is a set that contains all the possible outcomes. So first off, I'm flipping a coin. The results for that are heads and tails, right? And we'll represent tails with a T, capital T, H, heads with capital H, and then my sample space, like I said, it is a set. And what we're going to do is we're going to represent it with, we're going to list all the possible elements. So this is a curly brace. There's the first outcome. One outcome is heads, one outcome is tails. And that's it. So we close the brackets, or we close our curly braces. Next, standing a roller die. That's just, I'm tired this afternoon. Rolling a standard die. Okay, so we're going with a standard 6-sided die. So you can come up with 1, 2, 3, 4, 5, or 6. Right? Those are all the possible outcomes, and they are listed in my sample space. Next, answers for a true or false question. Well, it could be true, it could be false. And then how about flipping 2 coins? Now, each element in the sample space is a possible outcome. So if I flip 2 coins, I'm not just flipping a single coin. So my first coin has an outcome, my second coin has an outcome. So it's not going to have just these 2 possibilities. So what I'm going to do is create a little tree, and we'll talk about these later. Here's my first toss, or my first coin, whichever it is, and then the second coin. All right, so after I flip the first coin, I then flip the second coin. The first coin can come out heads or tails. The second coin can come out heads or tails. Now, why did I use this table? Because now I can trace this tree back and get all the possible outcomes, right? This is a tree diagram, and this is called a leaf, the last element on there. I can trace that leaf all the way back to the stem of the tree, to the root of the tree. And if I come up starting here and I go to end up here at the top with that H, I have to go H, H. So that means that branch represents the possibility or the outcome H, H, which is heads and heads. Next, heads then tails. Next, tails then heads. And then the last one, tails and tails. So my sample space, heads, 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 tails, tails, heads, tails, tails. I want to introduce that because I want you to see that what the outcome is. Doesn't have to just be a single element. It doesn't have to be just heads or just tails. Now I'm flipping 2 coins. What if I want to flip 3 coins, right? Well, each outcome is going to have 3 letters in it. It's going to have the first one can be heads or tails, the second one can be heads or tails, the third one can be heads or tails. I know this one seems a little elementary based on what we've done, but using that tree is good so that what it does is it helps you avoid missing any of the cases. It avoids you doubling up and writing the same one twice, and it avoids you missing out on a possible outcome.